If you're looking at this problem and freaking out because we're dividing by a trinomial, chill. It's really, really not that bad. First thing you should always do is check to see if you have any missing terms. We start with 2x to the fourth. We have 4x to the third, 5x squared, 3x minus 2. We do not have any missing terms that require a 0. We are dividing by x squared plus 2x minus 3. The good news is, for most of the division, the 2x minus 3 really doesn't matter. We are going to be focusing on the x squared and what we have to multiply by to get our required term. So our first cycle, x squared times what is going to give us 2x to the fourth. We need the 2 in there, and to go from x squared to x to the fourth, we need another x squared. Ooh, that's a really messy looking x squared. Then we distribute. This time we have to distribute it to all 3 terms. This is when the 3 terms matters, and write our answer below. So 2x squared times x squared is 2x to the fourth. 2x squared times 2x is 4x to the third. 2x squared times negative 3 is negative 6x squared. Now, what happens in this step is not always going to happen, but sometimes it does, and that's why I wanted to show this example to you. When we subtract 2x to the fourth minus 2x to the fourth, that cancels out and gives us 0. What is 4x to the third minus 4x to the third? Another 0, which means it also is going to cancel out that spot. We are going to end up not writing anything in that spot. It's going to be like a blank placeholder. Negative 5x squared minus 6x squared. Negative 5 minus a negative 6, that would be positive 1x squared. Bring your next term down. And let's start our second sequence, our second cycle. Because we are trying to get 1x squared, we're trying to fill in the blank that is directly above that. So see how we've skipped over the second column. So x squared times what would give us 1x squared? Just a 1. Distribute. 1 times x squared is 1x squared. 1 times 2x is 2x. And 1 times negative 3 is negative 3. Before we start subtracting, do you see anything wrong with our subtraction problem? Right, we have this hole above negative 3. Whenever you have a hole, you can bring down the term from above. You don't want to put a 0 in there. You have something you can drop into that spot, so drop that thing into the spot. Anytime you're dividing by a trinomial, you'll commonly have to drop down the next 2 terms in order to not have any holes. 1x squared minus 1x squared is 0. I did not tell you to get bigger like that. Come on now. 3x minus 2x would be 1x. And negative 2 minus a negative 3 would be positive 1. Okay, now here's the real interesting thing about this trinomial that we're dividing by. If I want to figure out what goes in that light green blank, let's think about this for a minute. Can I do x squared times something to give me 1x? If I'm already at x squared, I can't multiply by something and then suddenly have a smaller exponent. So this is actually the end. This is going to be our remainder. Our final answer would be this stuff on the top and our remainder. We write it like this. 2x squared plus 1. And we don't just write remainder 1x plus 1. We put plus 1x plus 1 over x squared plus 2x minus 3. You always put the remainder over whatever it is that you originally divided by. Kind of like in our first example when we had the remainder, like with just numbers, we put the remainder over the number that we had divided by. I think in your notes, when you look at the back page at what the assignments are, I think it says fewer problems than what it says on the assignment slide that I'm about to show you. What does it say on there?
1, 25, 27, 28, 30.
It does say 28 to 30 even?
Yes.
Okay. So let's do, yeah, basically 25, 27, 28, and 30. Just those 4 problems. That way you're only doing 4 problems instead of 5 problems.